Hi everyone, welcome to the DILR video solutions for CAT 23 slot 1. Now, everybody's been talking about quant being very difficult in CAT 23 and people have kind of forgotten that DILR has been difficult for the last couple of years and slot 1 had maybe one of the most terrible sets out of all the three slots. That is the first set of slot 1, which is the visa processing office set. Let's have a look at it and let's start. So a visa processing office accepts visa applications in 4 categories. So 4 different things are there. That is for US, UK, Schengen and others. There are 4 such categories. The applications are scheduled for processing 20 15-minute slots. So there are 20 slots of 15 minutes each, starting at 9 a.m. and ending at 2 p.m. 10 applications are scheduled in each slot and there are 10 counters which they are mentioned over here. There are 10 counters. So 10 applications in each slot and there are a total of 10 counters in the office. 4 dedicated to US application and 2 each for UK, Schengen and other application. So total 10 applications are going to be accepted in each slot. There are a total of 10 counters. The most probable thinking is that for one counter, one application. But well, maybe that works or doesn't work, we'll see. Okay. Applicants are called for processing sequentially on a first come first serve basis whenever a counter gets freed for their category. So applicants are called only obviously for their category. That means if you're going to UK, you're not going to go to the US counter. If you're going to the US, you're not going to the UK counter and so on. So every counter is different. The processing time for an application is the same within each category. So within each category, every processing takes the same amount of time. That means that for US, they have told us, which they have told us at some stage, for US, if they have told us 10 minutes is the processing time for one visa application, it will remain 10 minutes throughout the day, right? Okay, so processing, but it may vary across the categories. Obviously, for US, UK, they have told us 10 minutes, but for the other two, is they are not told, it could vary also. Each US and UK application requires 10 minutes. What I was just telling you, they've told us that depending on the number of applications in a category and time required to process an application for that category, it is possible that an applicant for a slot may be processed later. That means how many people have applied in one slot and how many counters are available or how much time it takes. Based on that, people might get delayed. Very, very, very important statement. So this, according to me, was a very important statement. There can be delay because of 2 reasons. Basically, that they have given more, they've called more people of a particular country visa application than the number of counters available. And because of that, there will be a delay, or they're taking more than 15 minutes and because of which there could be a delay. Okay. Now, on a particular day, Ira, Vijay and Nandini were scheduled for Schengen visa. So, these 3 people were scheduled for Schengen visa processing in that order. So, first Ira, then Vijay and Nandini. They had a 9:15 a.m. slot but entered the VPO at 9:20. That means they were delayed by 5 minutes. So, their slot was supposed to be 9:15 but they all came at 9:20. Now comes the crux of the set, which we feel was the most, the statement which was the most debatable statement, and because of which we are going to challenge 2 questions of this set. When they entered the office, exactly 6 out of the 10 counters were either processing applications or had finished processing one and ready to start processing next. Now tell me, what can a counter be doing? What can a person in a counter be doing? He is either processing or he has finished processing and is waiting for somebody. Is there anything else he could be doing? I could not think of it. Obviously, I'll discuss more in detail as we go ahead. But that is where they said 6 of them were doing this. So what were the remaining 4 counters doing? I could not understand that part itself. And hence, this set I thought was, because of this statement, was very ambiguous. And because of which 2 questions become ambiguous. Obviously, 3 of them don't depend on this statement and we'll come to that later. Mahira and Osman were scheduled in the 9:30 a.m. slot on that day for visa processing or in the others category. 5 more points were given. All slots were full for that day. So all slots were full that day, which means totally 10 into 20, 200 slots were given. The number of US applications was same in all the slots. This was true for other categories also. 50% of the application were US. So 100 out of the 200 were US. All applicants except Ira, Vijay and Nandini arrived on time, and Vijay was called to a counter at 9:25 a.m. Now, let's have a look at the question, and we'll also talk about the question which was slightly debatable. How many UK applications were scheduled on that day? This I thought was one of the, out of the 5, was one of the most straightforward question. Okay, this comes very easily. What is the maximum possible value of the time in minutes nearest to its nearest integer value required to process all the applications in the others category? So this was a debatable question. We'll come to this later. Which of the following is the closest to the time when Nandini's application process got over? This can be done, not straightforward, but can be done without that use of that particular statement. Which of the following statements is false? We'll come back to this also later. This was slightly debatable. Or once you assume something from that statement, you get this question also. When did the application process for all US applications get over on that day? This can also be done. So 3 questions can be done, which I'm going to do first, then attack that statement. What have we interpreted it as, and explain that to you. Let's go ahead further. Now, I have just taken the same data and reduced it by removing a lot of things which were not needed. So I've just put down everything properly. 20 slots of 15 minutes, each starting at 9 a.m., ending at 2 p.m. 10 applications are scheduled in each slot. Counters are totally 10, US 4, UK 2, Schengen 2, others 2. Processing time, US 10, UK 10, Schengen others not known. Processing time for an application is same within each category, but it may vary across category. Obviously, that is why these two can be different. Depending on the number of applications in a category, time required to process, as I told you, was a very important statement, that they could be delayed because of 2 things. Either because the time taken was more than 15 minutes per, that means suppose Schengen took more than 15 minutes. People who were arriving there would be delayed, or more people were called for 2 reasons. Then that Ira, Vijay and Nandini had a 9:15 a.m. slot for Schengen visa, and so on. And we read the remaining points. And that point which was debatable, I've just put down in red. So you all just know that we're not touching that now. Let's look at these 5 points now, and let's go ahead with that much. So we know total applications were 200 because all slots were full. Out of which I know US applications is 100 exactly, because 50%, the third point says 50% are US. So US is 100. They have also mentioned that in every slot, okay, second point, the number of US applications and for all other 3 categories was the same in each slot. 20 slots were there. There were total 100 US applications. Therefore, 100 divided by 20 will be 5 applications in each slot. So can I say there were 5 applications of US out of the total 10 in one time slot? Every time slot had 10 applications, out of which 5 were US, right? We still don't know what the other 5 were. Now, let's look at the next part. Ira, Vijay and Nandini had a 9:15 a.m. slot for Schengen visa. Now, what does that mean? 3 people were called in one slot for Schengen. So can I say for Schengen, minimum 3 people were called? I don't know whether more than 3 were called or not, but minimum 3 were called. And same way, Mahira and Osman were scheduled in the 9:30 a.m. slot for others category, which means for others category, minimum 2 people are being called. Again, there could be more than 2 also. They haven't said only Mahira and Osman were called, but that. Now, even if I count this minimum, I will reach my 10 because US is already 5 and minimum 3 for Schengen and minimum 2 for others. That completes 10. So what does that tell me? That tells me this is exactly 3 and exactly 2. I know a lot of people have already got the question, UK ka kya, sir? We'll come to that. So there are 3 applications for Schengen and 2 applications of others in one time slot. This is definitely true. Others category. Now, which means UK is definitely 0. That means in any of the time slot, there is no UK. UK is 0. If UK is 0 in one time slot, UK is 0 throughout the day. And hence, what do we get? Is we get UK is 0 throughout the day. US is 100 throughout the day. Schengen is 60 throughout the day. And others are 20 throughout the day. 40 throughout the day. And that makes up your 200. Right? Let's continue. Now, same data again. Now we are going to first Schengen and try and answer a couple of questions related to Schengen. Now, what happened? Now, let's understand. We know that 3 people are given time slot. In every time slot, 3 people are called for Schengen visa. Okay, that means at 9 o'clock exactly, 3 people arrived. 9:15, 3 people were supposed to arrive, but they did not arrive. And they arrived at 9:20, and these are the only people who were late. After that, everybody obviously came. So these people came at 9:20. Then 9:30, 3 people came. 9:45, 3 people came. And so on. This process will keep continuing. So, and there are only 2 counters. So, obviously there is going to be a delay. Now, there might not have been a delay because we don't know what the time is. So 9, we don't know what time did that. This is this number 1, the which I have written in the circle, is the application number 1 or applicant number 1 who came first that day. Came in at 9 o'clock. We don't know when he or she finished his work, and that is why I've left that blank. Same way, applicant number 2 also came in at 9 o'clock. Don't know what time it finished. Applicant 3, we don't know what time he or she came, and what time did he finish. He came at 9, but he don't know what time. We don't know what time he went to the counter. So this could have been at 9:10, 9:15, whatever time, I don't know. Right? 9:15, 3 people were supposed to come, but they could not come. They came at 9:20. So 9:20. This is also actually not true. We don't know what time Ira went. So this is also, just hold on to this. I don't know right now what time Ira went. So we'll just come to that later. Let's leave that blank for Ira because Ira came at 9:20. We don't know whether Ira went at 9:20. Could have gone at 9:21, 22, 23, whenever time. Only thing I know, Vijay was called at 9:25. Now that made it very important. Vijay was called at 9:25. That means counter number 1, where Vijay is supposed to go. Do you understand why Vijay is going to counter number 1? Because Vijay is the 5th applicant. 3 people came at 9 o'clock. 3 people came at 9:20, in which Ira was number 4. Vijay was number 5. So Vijay will go to counter number 5 and Nandini will go to counter number 6. Now, because Vijay is being called at 9:25 exactly, he came at 9:20, which means he waited 5 minutes. Which means the counter was not free at 9:20, not at 9:21, 22, 23. The counter was not free, which means this counter got free exactly at 9:25. That means 2 people were able to finish exactly in 25 minutes, which means one person's time taken is 12.5 minutes for Schengen visa. So Schengen visa, one person is taking 12.5 minutes, 12 minutes, 30 seconds. Go through this very, very carefully because Vijay went exactly at 9:25 to a counter. We know that 2 people are able to finish in 25 minutes, and therefore the Schengen visa time is 12.5 minutes. So now we know that 9 o'clock, the first person went, finished at 9:12, 30 seconds. Same thing happened in the second counter also. Third person went at 9:12, 30 and finished at 9:25. Ira went at 9:20. So I will just erase this now for you all, so there is no confusion. Ira went at 9:20 and finished at 9:30 to 30. Vijay went at 9:25, finished at 9:37:30. Obviously, everybody takes the same time. When did Nandini go? Nandini went at 9:30 to 30 and finished at 9:45. So we finished everything about Schengen visa. Let's try and answer a couple of questions based on this much. How many UK applications were scheduled on that day? We know that UK was 0 and throughout the day also UK remained 0, which means the required answer for this question is 0. I noticed in this year, first time a couple of TETA questions were 0. There were some other sets also where TETA questions had 0 answer. Very rarely that used to happen. This time that's happened 2-3 times. Next one, which of the following is the closest to the time when Nandini's application process got over? So we in fact know the exact time. Nandini finished exactly at 9:45. If you understood the Schengen part, Nandini finished exactly at 9:45. Answer is the third option. But remember, this is question 3. I have skipped question 2. And I've also skipped question 4. This is question 5. When did the application process for all US applications get over that day? Now this I'll have to work a little bit extra. We have this much data. Let's make a table for US. The way we made for Schengen, let's make for US. US, I already know the time is 10 minutes. So that much was easier. There is no ambiguity and there are no names in US. So only thing I know that at 9 o'clock, exactly 5 people came. 9:15, 5 people came. 9:30, 5 people came. And so on, so on, so on. Last 5 people came at 1:45. In fact, that's when did the application process for all US application get over on that day. So when these people came, when did their work get over was the answer we wanted, right? Let's pay attention what happens. Let's try and look at a pattern. So the first person came at 9 o'clock, finished at 9:10, second, third, fourth. All these were same because there were 4 counters, even though 5 people came, but 4 people could go to the counters, 1 person had to wait. At 9:10, as soon as the counter got free, he went immediately to counter number 1. Obviously, we're assuming that they are going in an order. So at 9:20, the first lot of people finished their work. The first 5 were able to finish, all of them were able to finish their work at 9:20. Now, when did application 6 come? He came only at 9:15. So even if this counter is free at 9:10, there is no point. He came only at 9:15. So 9:15 to 9:25, 9:15 to 9:25, 9:15 to 9:25. 3 are done. From that is 6, 7, 8. Ninth number will go at 9:20, finish at 9:30. 10th number will go at 9:25, finish at 9:35. That means these people are finishing at 9:35. These 5 are finishing, and that is I just made that bold also there. Next 5, just to show it to you, a lot of people have got the answer here also. 9:30 to 9:40, 9:30 because they came only at 9:30. 9:30 to 9:40, 9:30 to 9:40, 9:35 to 9:45, and last one 9:40 to 9:50. So these people finish at 9:50. So if you look properly, they finish exactly 20 minutes after they come. The ones who came at 9, all of them finished their work by 9:20. Suppose they were all 5 friends, they finished by 9:20. 9:15 finishes at 9:35. 9:30 finishes at 9:50. So obviously 1:45 finishes at what time? 2:05. That is the first option. I know, literally impossible to think of all this in an exam scenario with the pressure you have in an exam. So obviously we're calling this as a level C set. We're not even thinking about solving it, right? Let's go to the next part now. Now we still have to answer 2 more questions, and we're going to work with that red statement. We know that Ira, Vijay and Nandini had a 9:15 slot. They came at 9:20. When they entered the office, what did they see? They saw exactly 6 out of the 10 counters were either processing applications or had finished processing one and ready to start processing the other. That means the 2 UK counters, so I'm going to kind of say they were useless. They were neither processing, neither had they finished processing. Fair enough. So I'm still left with 8 counters. Out of the 8, I have to figure out what are 6 of them doing. So let's see what is counter number 1 of Schengen doing at 9:20. So at 9:20, can I say 2 counters of UK will not be considered? At 9:20, can I say this counter is processing? This is under processing. It is processing somebody's application. At 9:20, what about counter number 2? That was free and ready to process somebody because it processed Ira. So counter 2 will be under the ready category, right? So both the counters are considered in that 6 of Schengen. Now let's look at US. What about counter 1 at 9:20? At 9:20, it has just finished somebody's work and is ready to process first class. R category, I've put in 2 categories, either it's ready or it is processing. Counter 2, 3 and 4. So no debate, they are all processing, right? Now the problem is, what are the 2 others ka counter doing? Why are they being not considered in this case? And what is the assumption we made? And we have not made the assumption on our own. We have back calculated from the answers provided by CAT. And I'm being very frank over here. It's not that we've thought of it and discovered the answer. We back calculated from the answers. And we have arrived to a logic that what CAT wanted to say was through this statement was that they are talking about those counters which are ready for processing and an applicant is ready in front of them also. So basically, why did the 2 others counters not get counted in this 6 category was because they at 9:20 were free. They both were free. The 2 counters were free, but the applicant was not in front of them. That means, in short, the applicant which came at 9:15 finished the work by 9:20, which means the counters were not processing. Otherwise, they would have gone under the processing category. But because the 9:30 candidate has still not come in, or the applicant has still not come in, they are not ready for processing. And that is the debate. And obviously, because of that, we are going to raise a question for this. So now what do we have? The 2 counters or others will not be considered in the above 6, which means they are not processing and they cannot start a new process as the new applicant has not arrived. So same way I just made the others ka table. So we also know that Mahira and Osman were scheduled in the 9:30 a.m. slot on that day for visa processing in the others category, right? So now let's look at it. The first counter started at 9 o'clock. 2 people came at 9 o'clock and they ended by some time. Second one also did that. Assumption is they took less than 15 minutes. Or even if they took more than 15, they didn't take more than 15 minutes because 9:15 to max 9:20. At 9:20 when they finished, see, remember they could not be processing. If they were still processing the visa, that means if this time was more than 5 minutes, if they were still processing the visa, what would have happened? They would be considered under the processing category. And because they're not being considered under the processing category, therefore 9:15 to max 9:20 is where they can go, which means the maximum time slot for the others category is 5. It could be 1 minute, 2 minutes, 3 minutes, 3.5 minutes. Doesn't matter. Maximum is 5 minutes and so on. And hence, Mahira went in at 9:30, finished max by 9:35. Osman went at 9:30 and finished max by 9:35. Obviously, as I said, this we have worked backwards from the answer. The answer given for this question was 200. There were 40 slots, 200 divided by 4, maximum 5. So we've kind of worked backwards, got the logic and are explaining it to you. So now we have the others category. The answer will be, because it is 5 minutes maximum for one slot. So for 4 slots, so for 20 slots, it will 40 people, it will be 200 minutes. Hence the answer for this question is 200. Once you assume that, the last question also should be pretty straightforward. In fact, the last question looks very, very straightforward. So I've just put down the 2 tables over here. The first option says what? The application process for Mahira started after Nandini. According to us, Mahira has started at what time? Look at Mahira. Mahira started at 9:30 and Nandini has started at 9:32. So that statement is false. Started after, they're saying. According to us, it is true and they wanted a false statement. So that itself is my answer. Immediately I know. But just to explain, because it was such a difficult set, I decided to go through the 3 other options also. Option 2, the application process for Mahira was completed after Nandini. Mahira finished at 9:35. Look at Mahira finishing 9:35 while Nandini finished at 9:45, right? So Mahira was completed before Nandini. Yes, it is true. So this is a true statement. Next, the application process of Osman was completed before 9:45. Osman is completed at 9:35 maximum. So this statement is also true. And last one, the application process of Osman was completed before Vijay. Osman is definitely completed before Vijay. Vijay has finished at 9:37. And that's the 4th option, right? So we've got 4th option is also true. So 3 true and 1 false. And that is my first is my answer. So again, with all the debate, I know there's going to be a lot of debate on comments that, sir, how can we ever think of all this? I'll try and answer all the comments which you all put up for this set. But right now, this is the best solution we have. We'll have to wait for what CAT says. Do they not consider these 2 questions or they give marks to everybody? We'll have to wait for that. Anyways, this would have been definitely a category C set. Means even if they had put a little bit better conditions for those statements, still it would have been a category C set, something which you should have definitely avoided in this slot. Let's have a look at the next set of DILR from slot 1. I thought this was a much easier set than the previous one and a pretty manageable one as so. Let's read. So they've spoken about faculty members in the management school can belong to any of the 4 departments. There are 4 departments: finance, marketing, operations, and behavior. No point wasting your time reading everything. The number of faculty members in each of these departments were 9,753 respectively, which means we know exactly how many faculty members are there. Professor P, Q, R and S are 4 members of the school's faculty who are candidates for the post of dean. So out of these 4, the dean will be selected. Only one of the candidates was from O and Q. So O and Q had only one candidate. There were 4 candidates and there were 4 departments. There was a possibility that each of them belonged to one, but let's read further. Every faculty member, including the 4 candidates, voted for the post. That means everybody voted. That means these 9,753, everybody voted, including the ones who were standing for the elections also. In each department, all the faculty members who were not candidates voted for the same candidate. Very importantly, that means suppose in the first department there were 9 people and there was say only one candidate. That means the remaining 8 voted for the same candidate. The rules for the election are listed as below. There cannot be more than 2 candidates from a single department. That means maximum 2 candidates per department. A candidate cannot vote for himself or herself, so he'll vote for somebody random. Faculty members cannot vote for a candidate from their own department. That means these 9 suppose if one of them was a candidate, they cannot vote for their own department, people from their own department. That's fair enough. After the election, it was observed that P received 3 votes, Professor P received 3 votes, Q received 14 votes, R received 6 votes, and S received 1 vote. And they've also told which of the professors who was standing for the dean has voted for whom. So those 4 conditions also given. Let's read the questions now. So what is there in the questions? Which 2 candidates can belong to the same department? In fact, this question can belong. Okay, more or less tells me that there was one department where there were 2 candidates standing. We know O and Q had only 1, right? So that was one part. Which of the following can be the number of votes received by Professor Q? Now, Professor Q has received higher votes, so we'll come to know whether he received 9, 8, 7, 6, whatever. We'll see. If Professor, and then there are 2 ifs. So the if also becomes very important. As soon as there is a if Professor S belongs to B and H, which means when I make my conditions and everything, I don't have to finish everything because it starts with the if. And what can be best concluded about candidate from O and Q. So all these things tell me that the table or whatever I will create might not finish off completely. So not too much worry. Let's go ahead and let's see what we would do. So this is the data we already have. Now let's try and form a table. We could have also done on rough work, just put the data down in rough and also done it, but just formed a table to make it slightly more presentable. Now, what is the main data we had? We know that all the faculty members who are not candidates voted for the same candidate, right? And we also know who received how many votes. Now we know Q received 14 votes and so on. But there was also a point where they have told us, see, Professor P voted for R. So we know that P has voted for R. Q has voted for S, R has voted for Q, and S has voted for P, right? These are the things. That means all of them have already got 1 vote. P, Q, R, S, all of them have already got 1 vote. So, P, who was to receive 3 votes, needs 2 more votes. Q, who was to receive 14 votes, now needs 13 votes. And R, who was to receive 6 votes, now will need 5 more votes. And S will not need any votes because he has got only 1 vote, and that 1 vote he has already got over here, right? So that part is done. Now, what is it? Now, over here, I'm going to try and put the others who voted. So, other, that means except the people who are going to stand themselves for the elections, the others who have voted. Now, let's start with P. Say P who had to get 2 votes over here. Now think, which is the only department which can give P 2 votes, right? So for example, we already know from O and Q, there was only 1 person standing. And that person, that means that other members of O and Q, 4 members would vote. So they will not be able to give P 2 votes. So the only way 2 can come is from B and H, because B and H had total of 3, and which means 1 more person was standing as a candidate from there, and we got 2 over here. So 1 person was standing as a candidate from B and H, and that the remaining 2 people have voted for P. So therefore I get my P over here. Same way, let's look at R as 5. Where can R get 5 from? From the data now which we have, it is very clear R can get 5 only from here, which means there are 2 candidates for from MNS, and these 5 have voted therefore for R, right? R they have voted for. Now, which means there is nobody standing as a candidate from FNA, which means there are 9 people who are going to vote, and they will obviously all vote for Q. And 9 plus 4, 13 people will vote for Q because S did not require any votes. Now, since I know FNA, nobody is standing as a candidate. So basically, now I'm going to try and find out who's the candidate in which department. So here there are no candidates, right? Since R is already over here, MNS have already voted for R. So can I say MNS cannot have R? So can I say here the possibility are only P, Q and S? Same way, O and Q have already voted for Q. So therefore, they cannot have Q. So they can have P, R or S. And same way, since the last have voted for P, B and H have voted for P, they can have only Q, R or S. Right? Let's go ahead now that much. Now, let's see what else can we do. Now, from these votes, you'll be able to figure out who's not where. Q has voted for S. Q has voted for S, which means Q and S both cannot be in the same department. If Q has voted for S, Q and S both cannot be in the same department. And hence over here, since we want 2, P is definitely one of them. One out of Q and S is there. So that means there is no P over here. Right? That much we got. Now, let's understand who else has voted for whom. R has voted for Q. R has voted for Q. Does it tell me anything over here? That means R and Q cannot be together. But still, there was only one person, which means it could be Q and S, R and S. I don't know. So this is not telling me much. I have used that. S has voted for P. S has voted for P, which means S and P cannot be together. P I already know. S and P cannot be together. So S cannot be here. So Q is definitely over here. So Q cannot come. Right, which means now we know that from M and S there are 2 people which are P and Q. This R and S we will not be able to figure out, so this will more or less remain as it is. So now what do we know? We know from FNA there are no candidates, from MNS there are 2 candidates P and Q, from O and Q there are 2 candidates R and S, and from B and H there are 2 candidates R and S, and based on this you should be able to easily answer all the questions. Now, let's go ahead. Which 2 candidates can belong to the same department? This is what we've already done behind. I've just taken the same data. Now, 2 candidates belonging to the same department can be P and Q. So, we have Professor P and Q which belong to the MS department, and hence the answer will be the 4th option. Next question. Which of the following can be the number of votes that Q received from a single department? Now, whereas Q received votes, it has received 9 or 4 votes. Now, option does not have a 4, and hence the answer will be 9, which is the first option. Next question. If S belongs to B and H, now that is where things are changing. B and H, if this is S, which means this will become R. So let's just change that. Let's make that S and let's make that R. Which of the following statements is or are true? Professor P belongs to M and S. Where does P belong? Does P belong to M and S? Yes. So that statement is true. Statement B, Professor R belongs to O and Q. R belongs to O and Q. Yes, that statement is also true. That is if, with the if it belongs. And hence both the statements are true. So answer will be the 4th option. Both statement A and B are true. Next question. What best can be concluded about the candidates from O and Q? So what do we know about O and Q? It will be either R or S, right? And hence the answer will be the 3rd option. That is either R or S. We don't know that is surely. Obviously, what we had used in the previous question cannot be used ahead. Next one. Which of the following candidates is or which of the following statements is or are true? No if is given directly. Non-candidates from MNS voted for Q. So MNS, have they voted for Q? No, they haven't voted for Q. They have voted for R. So statement 1 is wrong. And non-candidates from FNA voted for Q. FNA, did they vote for Q? Yes, they voted for Q. So that statement is correct. So statement A is incorrect and statement B is correct. So only statement B, which will be the 3rd option. So according to me, a pretty doable set. You could have easily done this set. It was not so difficult. Just get that first initial logic right of how to go about it. And compare it to the first set, which was a very difficult one. And hence this was a very, very doable set. I would have definitely done this set in an exam scenario. Let's have a look at the next set. The next set was not as easy as the earlier one, but maybe not as difficult also. So let's have a look. The schematic diagram below shows 12 rectangular houses in a housing complex. House numbers are mentioned in the rectangle representing the house. So these are 12 houses, A1, B1, C1, D1, E1, F1, and same way A2 to F2 also. So there's row 1, row 2. The houses are divided into 2 blocks, block XX, block YY, 6 houses in each block. There is road in the middle also and the road on the side also. Let's read the part over here. Some of the houses are occupied, the remaining ones are vacant, and only the ones are available for sale. So there is 2 categories of houses. They are either occupied or they are vacant, and only if they are vacant, they can be sold or they are available for sale. Right? Let's read further. The road adjacency value of a house is the number of its sides adjacent to a road. So for example, for this house, for C2, there are 2 roads it is adjacent to, while E1 is adjacent to 0 roads, while F2 is adjacent to 1 road, and so on. So every house is adjacent to different number of roads, Based on that, they have told something. And then the second category is there can be also about neighbors. So for example, B1 can have maximum 3 neighbors. They can have neighbors as A1, C1 and B2. So B1, B2 and E1, E2 can have 3 neighbors. I think rest everybody can have 2 neighbors. B1, B2, E1, E2 can have 3 neighbors. Rest everybody can have 2 neighbors. Nobody can have 0 neighbors. Yes, but the neighbors should be occupied. If the neighbors are not occupied, they will still be considered 0. Okay. So for example, if A2 has 2 neighbors, B2 and A1, but if they both are unoccupied, then we say that A1, A2 has 0 neighbors. And based on this, the price of the house is taken as the base price is 10 lakhs. If it has parking, the base price becomes 12 lakhs. That means 2 lakhs for parking. And the quoted price depends on other things. That is the base price plus 5 times the road adjacency. Now, road adjacency does not depend on anybody else, whether the house is vacant or not. Right? So, F2, if it is vacant and it is going to be sold, its road adjacency will always be 1. And if D2 is to be sold, its road adjacency will be 2. Nobody can have more than 2 road adjacency, and neighbor count can be maximum 3. So plus 3 times of that. So for every road you're adjacent to, you will get 5 lakhs extra. And if you have one neighbor, you'll get 3 lakh extra and so on. There were some more statements. We'll work with those statements also. Now let's look at the other statements. The maximum quoted price of the house of block XX is 24 lakhs. So there is one block. In block XX, there is one house which is at 24 lakhs. And that is the maximum. Nobody has more than 24 lakhs. Well, there could be more than one house also at 24 lakhs. The minimum quoted price for a block YY house is 15 lakhs. There's nothing below 15 lakhs. And one such house is in column E. They have told us 15 lakhs, one house is in column E. Row 1 has 2 occupied houses, 1 in each block. So row 1 has only 2 occupied houses. That means out of the 6 houses in row 1, only 2 are occupied and 4 are free. Both houses in column E are vacant. Right? And all that. But these points, now when I have the data, it will be easy to interpret. So we'll talk about it later. Let's have a look at the question. How many houses are vacant in block X? And since it's a theta question, I know I'm going to be able to find the answer. Which of the following houses is definitely occupied? One question where cat has gone wrong. I think 2 options are correct. And again, this is a question we're going to debate on. Which of the following options best describes the number of vacant houses in row 2? So there are either options and all that. What is the maximum possible quoted price in rupees per lakh for a house, vacant house in column E? And which house is block Y has parking space? Well, looks like a pretty doable set. Let's have a look at it. Except that one question which is the problem, because of which there was a slight debate on this set. So base price can be 10 or 12 depending on your parking space. Second, road adjacency. If you don't have any road adjacent to you, you will get 0 for it. 1 road adjacent, you will get 5. 2 road adjacents, you will get 10. And neighbor count will be 0, 3, 6 or 9. Right? So we've got that much. Now, let's read further. I have taken the second point. Row 1 has 2 occupied houses, 1 in each block, which means it has 4 vacant houses also. Now, let's start with what we have and let's try and figure out what we get. Now see, what I'm going to do over here, I know E1 and E2 are definitely vacant. See, both houses in column E are vacant. So vacant, I'm putting a red circle and green circle I will use for occupied. So column E, both houses are vacant, E1 and E2, right? Further. Now let's go to block X and see what is the maximize. The only possible way to maximize the price of a house to 24 lakhs is what? Now think, how can you get 24 lakhs? You have to take numbers from here. So if you took 10 and 10, you will never reach 24. You will reach 23, 26 or 29, which means you can't take 10 and 10. What if you took 10 and 5? So you could take 10, 5 and 9, no problem. That can be one possibility. What if I took 12 with something? 12 with 9 is maximum 21, so I can't just take 0. 12 with 10 becomes 2, use 22 plus 3 becomes minimum 25. 12 plus 5, 17, there is no 7. So the only way I can reach 24 lakhs is this amount, 10 plus 5 plus 9, which is 24, which means it has to have only one road facing. It has to have only one road facing. So in short, it is not C2 is not that house, right? It is in block 1. So it has to have one road facing, no parking. Parking, anyway, I don't know right now. but it has to have 3 neighbors, and we already said right at the start, only B1, B2, E1, E2 can have 3 neighbors. So it has to have a road facing also, and it has to have 3 neighbors also. B1 does not have a road facing, which means the only possibility over here is B2, right? One road face, and B2 is the only possible house, and therefore B2 is a vacant house whose price is 24 lakhs. No parking because 10 lakhs I have taken. So B2 does not have a parking, right? We got that much. So we got which is the house with the maximum price in block X. Now let's go to block Y. Right now, I also know that B2 has 3 neighbors, and these 3 neighbors are occupied, which means A2 has to be occupied, C2 has to be occupied, and even B1 has to be occupied. And I know that in the first row, there is only one house occupied, and hence A1 and C1 are both unoccupied. These are vacant. So in block X, there are 3 vacant houses and 3 occupied houses. I got which is the house with 24 lakhs. And I think 1 or 2 questions you are able to answer from here. There are 2 possible ways to minimize the price of a block YY to 15 lakhs. Now see, if I want to minimize something to 15 lakhs, I can do it as 1050, or I can do it as 1203. Now, one of the houses of column E had to be at 15 lakhs, they had said. So let's think, can it be 1050? Now, if this is 10, right? If this is 10, E2. Now, I have written it down, so let's just understand it. Now, D2 and F2 are both not possible, right? Because if D2 has two roads, so that is not possible. F2 is not possible because, now pay attention to this very carefully. Why can F2 be not 10, 5 and 0? Because they have said that if F2 is vacant, then F1 will have to be, see, read this part very carefully. Column D and column F has at least one occupied house. So if I'm considering F2 vacant, then F1 will definitely be the neighbor who's occupied, so that 3 will get added. So 10, 5, 0 is not possible for D2 and F2. E2 is not possible because if E2 has a 10 and it has a roads of 5. Now, 1 out of D2 and F2 will have to be occupied because of the statement, because they have told us row 1 has only one. They have told us row 1 has only 2 occupied houses, right? And which means only 1 out of these 2 can be occupied. Both cannot be occupied, which means 1 out of D2 or F2 will have to be occupied. So it will have one neighbor. So this 1050 is not possible here also. Now, since 1050 is not possible, they will have to be 1203 for E1. So I have to literally fit that in. E1 is possible, 1203 how? E1 can have parking, so 12. It can have one neighbor, so 1 out of D1 and F1 definitely we know is occupied. We don't know which one. Right now we don't know which one. We'll see what. One of them is definitely occupied, and hence we know that E1 is that house with 15 lakhs. Now came the point where everything was very debatable. Lot of people at this point would have considered that D1 and F1, one of them is occupied and the other is not occupied. But the problem is, if I keep F1 vacant, then the price for F1 goes only to 13 lakhs. Let's think why. Because F1 now will not have a parking because the parking is gone to E1. There is only one parking. And F1 will be at 10 lakhs. It has no road. No, even if it takes one neighbor, right? F2. Then what will happen? It will go to only to 13 lakhs, and 13 lakhs is not allowed. Minimum is 15 lakhs. And this tells me that F1 is occupied. See, if it is occupied and its price is less, doesn't matter because it is not available for sale. So F1 is definitely occupied. So the green circle goes there. Now, if F1 is occupied, D1 will not be occupied. We know that in that row only one house was occupied. 1 out of D1 or D2. Now see, each of column D and F has at least one occupied house. Now, what about D2 and F2? Now, D2 will definitely become occupied because 1 out of D2 and D1 and D2 had to be occupied. So D2 becomes occupied. And F2 is the only house. Oh, I'll just erase all the ink. F2 is the only house which can be occupied or vacant. Very important. F2 is the only house which is occupied or vacant. It could be occupied also. It could be vacant also. Will not matter. Price of E2 can go up or go down. Will not matter. Based on this, we'll try and answer our questions. First question, how many houses are vacant in block X? Very straightforward. 3 houses are vacant. 1, 2 and 3. Next one, Which of the following is definitely occupied? Now, this was a question we were debating about, according to what we've got, B1 is also definitely occupied, right? We've got that occupied. And D2 is also definitely occupied. Answer given by CAT is B1. But according to us, even D2 will be definitely occupied. And this is the question we are going to raise a query for. So hence, this question is debatable. I think this question will definitely get cancelled out. Next one. Which of the following best describes the number of houses vacant in row 2? Now, vacant is red circle. So, 1 and 2 definitely, right? Vacant is 1 and 2. And this could be vacant or could not be vacant. So, we are not sure of that. So, answer will be 2 or 3, which is the third option. Next one. What is the maximum possible quoted price in lakh for a vacant house in column E? Now, I know E1 has already gone to how much? E1 has already gone to 15 lakhs. Now, what can E2 become? Let's see. E2 will have a maximum price of 21 lakhs. How? It does not have a parking. So, it will get 10 lakhs from the base price of the house. It has one road face. So 5 lakhs. It definitely has D2 as a neighbor. So, 3 lakhs. It can have F2 as a neighbor and cannot have F2 as a neighbor. So, another plus 3 lakhs. And it can hence go maximum to 21 lakhs. It can go out to a maximum of 21 lakhs. Next one. Which house in block Y has parking space? That we know very right from the start. We know parking space was at E1, 12 and 3 was the only way we had got it. So parking space is at E1. So this was it was a doable set. I would not say it was very difficult, but was not very easy also with that one debatable question. This would have been somewhere in between. I have thought that set 2 and set 4 are the easier set. This is the level B set and set 1 being the most difficult one. Let's have a look at the next set. This set I thought was one of the easier sets of this slot. Lot of students were complaining that they know mean, but they don't know median they don't know what does modal mean. Very frankly, these are very generic terms. You should have known them. And if you had known them, I thought this was a very, very straightforward set. And a lot of people just left it because of that. So let's just go through what they've told us. There are 5 restaurants coded R1 to R5 gave integral rating to 5 gig workers, Ulhas, Vasu, Vaman, Xavier and Yusuf on a scale of 1 to 5. So they gave them a rating from 1 to 5. The mean of the rating given by the restaurants were 3.4, 2.2, 3.8, 2.8 and 3.4. Multiply by 5, that will give you the total ratings. That's a very straightforward thing. We'll come to that later. The summary statistics of these rating for the 5 workers is given as below. Now, this is very important. Now, what was the mean rating for Ulhas? 2.2. Now, when I say mean is 2.2, which means the total was 11. The median was 2, which means if there are 5 values for Ulhas, the middle value was definitely 2. There could be more than 1, 2, or there could be only 1, 2 that I don't know, but there is definitely 2 in the middle. The modal rating is 2. What is modal? Mode. How many times does mode come? Basically, the value which is repeated the highest number of times is called the mode, which means there is minimum 1 more 2. There could be 2 more 2s also, I don't know, but there's minimum 1 more 2 that I know from here. And range is what? The difference between the highest rating minus the lowest rating. That means the highest and lowest are not 1 and 5 because the range is only 3. Wherever the range is 4, the highest are 1, the lowest is 1 and the highest is 5. Right? So that much we know from this table. We'll see further. The following is the partial information about ratings of 1 to 5 awarded by the restaurants to the workers. So some of the ratings they have told us that R1 awarded 5 to woman and all that we'll come to later. Now we'll first go and check the questions. Now what are the questions about? How many individual ratings can be determined from the above information? So from the information which we get, what table are we able to create? How many ratings are we able to determine for everybody? So that's the first question. This more or less kind of defines the whole set. If you can get the first question right, you are sure to get all the questions right. To how many workers did R2 give a rating of 4? As I said, once I know the first question, this is easy. What rating did R1 give to Xavier? What is the median or rating given by R3 to the 5 workers? And this is for R3 to the 5 workers and not from any other worker. Otherwise, the median was given in the table. Which of the following restaurants gave its median rating to exactly one of the workers? And here, this is one question which is a question with options. Otherwise, all 4 were theta. So I thought this was a very doable set. Let's have a look at it further. So what I'm doing is first I'm going to look at only this table and try and create my values for which I have to get for Ulhas and each of the 5 gig workers. Now for Ulhas, we're going to start with it. 2.2 was the mean. which means total was 2.2 into 5, which is 11. Now, I know the median is 2. That means the middlemost rating is 2. That's not from any restaurant. We still don't know anything about the restaurant, but this is 2. Now, as I said, there is definitely one more 2. So, let's just go to the rough work a little bit. And I want a total of 11 and a range of 3. Right? That means if I take a 1, I can't take a 5. And if I take a 5, I can't take a 1. So, let's think if I take 3 2s, something missing and 1 5. That itself becomes 11 because the range is 3. So, I need to take a 5. So, this is not possible, which means 3 2s are not there. That means there is a 1 over here definitely. There could be one more 2, I don't know. But now let's see. So, this 1, and which means this is not 5, this is 4, the largest value. So, the range becomes 3. 4 plus 1, 5, 5 plus 4, which we already have, 5 plus 2 plus 2. That is 9, and one more 2 will be there, which means this is 1, 2, 2 and 4. The range helps me to understand whether with 1 there is 4 or with 2 there is 5. I just had to figure that out, and once I figured that out, it was very easy. Right now, going to Vasu. Vasu's total is 3.8 into 5. That will become 19. Median is 4 and mode is also 4. So, median is 4 and mode is also 4 and range is only 3. Range is 3, which means it could be 5, 2 or again it could be 4, 1. So, are there more 4s than there is 1? I need a 19. Now, think if I gave 4 everywhere, I would reach 20. If I gave 4 everywhere, I would get 4 5s are 20. But I also want a range of 3. Right? I want a range of 3. So, if I take 4 4s and 1 1, that will not give me a range of, that will give me a range of 3, but it will not give me a total of 19. So, the total of 19, this was going to be 5 and 2, otherwise without which I don't think so we'll be able to reach 19. Let's check with this 4 4 4, that is 12, 12 plus 7, 19. We have reached, see, 4 4 4 plus 2 and 5. So, again, if you notice, I've taken the help of range a lot over here. Now, coming to Vaman, Vaman was 3.4. So, 3.4 into 5 is 17. Mode is 5 and median is 4. So, there are definitely at least 2 5s, which means these 2 will have to be 5s. And the range is 4, which means there has to be 1 1 at least. So, 5 plus 5, 10, 10 plus 4, 14, 14 plus 1, 15, plus 2, 17. So, I've got that also. Now, let's go to Xavier 3.6, which is 18. Again, mode is 5, median is 4. So, mode is 5. So, again, this will be 5, 5. Now, this time I need to reach a 18. So, this is already how much? And I know the range this time is again 4. So, this will again be 1. So, that's 10, 14, 15. Only thing change will be, this will be 3. So, between Vaman and Xavier, there was only one small change, 2 and 3. Yusuf is 2.6. 2.6 into 5 will become 13. Right? Mode is 1 and 4 and median is 3. So, 1 and 4, that means 1 has to come 2 times and 4 also has to come 2 times. Range is also okay. 8, 11, 11. Sorry, this has gone for a toss. We made some error somewhere. Let's check. This is 8 plus 3, 11, 11 plus 1, no, 12, 13. That's also right. It's coming to a total of 13. I made some small error. So, that's 13. So, this is one table where I've already got the scores of ratings for each of the 5 gig workers. Now, this is not done. You know, the set was still a lot more about what rating was given by whom. So, now I've taken the other data and now I've created this. So, from the previous page, I'm just going to take all the values over here so that it becomes easy for me. I'm just going to put the ratings down. So, for Ulhas, what were the ratings? Ulhas, the ratings were 1,224. 1,224 and 2,445. So, let's take that much. 1,224, 2,445. That is over here. For Vaman, what are the ratings I want? Let's check. Vaman was 1,2,455 and then 1,3,455. So, yeah, 1,2,455 and 1,3,455. That was for Xavier. And last for Yusuf, what do we have? Let's just check that. For Yusuf, it is 1,1,344. 1,1,344. So, we've got these ratings. Now, let's look at the total. We already know the total for each of them. Ulhas is what? Anyway, that total will not matter. Now, let's look at total of R1, R2, R3, R4 and R5. R1, the mean was 3.4. So 3.4 into 5 is 17. R2 is 2.2. So that will become 11. 3.8 into 5 is 19. 2.8 into 5 is 14. And 3.4 into 5 is 17. You can total it up both ways. You'll get the same total, right? Don't worry about that. Now, we can still check if you want. What was this? This is 6 plus 4, 10. 10 plus 1, 11. This is 12. 12 plus 7, 19. This is 3 plus 4, 7. 7 plus 10, 17. 4. 4 plus 4, 8. 8 plus 10, 18. 2, 5. 5 plus 8, 13. And let's just check. 11, 11, 19, 19, 17, 17, 31, 31, right? So the total is same. Okay. So now let's just check what else other information is given. We still have to read these two information very carefully. Right. R1 awarded a rating of 5 to woman. So R1 gave a 5 to woman. So we have used a 5 in woman. I've used 1 5 that will cut out over here. As did R2 to Xavier. R2 to Xavier also gave a 5. R3 to woman and Xavier. R3 to woman and Xavier gave a 5. So here both the 5s are gone. Xavier, both the 5s are gone. Right? And R5 to Vasu. R5 to Vasu is also a 5. So this 5 is also gone. So more or less all the 5s are gone. From the whole data, all the 5s which were given out. R1 gave a rating of 1 to Ulhas. R1 gave a 1 to Ulhas. So this is 1. So this 1 is gone. Next, and as did R2 to Waman and Yusuf. R2 to Waman and Yusuf. So here also 1 is gone, and here also 1 is gone. Yusuf. And R3 to Yusuf. R3 to Yusuf also gave a 1. So this 1 is also gone. So all the 1s are also gone. So 1 and 5s are done. Now we have to try and figure out the others. Now this was the main crux of the set, figuring out the remaining values. Let's check. Obviously, we'll start with the ones which are where least values are missing. So this was 11. We already have a total of 7. So we need 4 more. Now the 4 more can come in how many ways? If you look at what the remaining values are, there are only 2 and 4s left. There are no 3s and there is no 1. So which means the only way I can get is through 2 and 2. So this will be 2 and this will be 2 to reach 11. Right? That means 1, 2 from here and 1, 2 from here is utilized. So R2 is done. Now R3 is 11 already. We need to reach a 19. 10 plus 1 is 11. We need to reach a 19, which means we need 8 more. The only possibility is 4 and 4. So 4 and 4, this 4 and this 4 is also gone. Right? Now if you look at for Vasu, there are only 2 4s left, which means both the blank spaces will be 4. And same way for Ulhas, the 2 blank spaces will be 2, 2. So we have already finished everything for Ulhas and Vasu. If there are any questions related to them, you could have answered them. So what will you get for Vaman? You can have either a 2 or a 4 here. So this is 2 or 4, or you will have a 4 or a 2. Nothing else is possible for Vaman. Now for Xavier, I have 3 missing values, 1, 3 and 4. That means I'll have 1, 3 or 4 here. Either a 1, 3 or 4 here, or a 1, 3 or 4. Now understand that all the totals have to fit accordingly. And for Yusuf, we have a 3 or a 4. So we can have a 3 or 4. We can have 3 or 4, and we can have 3 or 4. Obviously, there were 2 4s. So hence the cases are only. Now I'm going to start with R4 and try and see what I want. I want a total of 14. Now, what are the different possibilities I can get 14? I've already got a 6 over here. I need 8 more. That 8 more can come as 2 plus 3 plus 3 with one case, or I can get 4, 1, 3. Right? 4, 1, 3. That is the other possibility. Right? This 4, 1 and 3. That's one more possibility. So I don't know which case is correct right now. So what you can do is you can start working with one of the case. If everything works out great, that's your case. If it doesn't work out, then that's not your case. So what we'll do is we'll just take a different color marker and we'll just try circling out. Say let's use a black color and let's try and circle out one of the case. Let's assume this 2 is correct. So what will happen if this 2 is correct? With 2 I need 3 and 3. So this 3 would be correct and this 3 would be correct. Now if this 2 is correct, this 4 is also has to be correct automatically. So now I have got this 4. Now with this 3 being correct, I have left with 1 or 4 over here. Now, how much is R1? R1 has already reached 9 plus 1, 10. I need to reach 7 more. So R1 basically cannot get a 1 over here. With 7 more, I cannot get a 1 over here. If 3 is chosen, I will have to choose 4 and then a 3 over here, right? With this 3, this kind of is not possible because both 2 3s are not possible, and hence this case was the wrong case. That was the important thing. Once you understood that this case is the wrong case, just let's get one more color and use the right case now. Say, let's use a green color and gets all the right cases. So this 4 is correct. With that, this 2 is correct, right? If I have this 4 correct, it will have to be 4, 1 and 3, right? The only possibility will be 4, 1, and this will now become 3. So we've got 4, 1, 3, which is also 8. Now, if I have got a 1 over here, I still can use 3 or 4 for Xavier, and we'll see that later. Now, how much is left over here? We have 3 or 4. So below this 2, I can use 3 or 4 or 3. But if you look over here, you already used a 3 in Yusuf, which means the 3 is gone. You will have to use 4 only for Yusuf. And you needed 17. So you'll have to use one more 4 over here. And this will also become 4. This is wrong. And this will be 3. So we've got the whole table, everything proper. For R1, it is 1, 4, 5, 3, 4. Let's check that. 7, 7 plus 5, 12. 12 plus 5, 17. For R4, it is 6, 6 plus 4, 10. 10 plus 1, 11. 11 plus 3, 14. That is also correct. For R5, it is 7. 7 plus 2, 9. 9 plus 8, 17 is also correct. So everything is correct. Based on that, we can easily answer the questions. So as I had said earlier only, once you're able to answer the first question, more or less are done. How many individual ratings cannot be determined from the above information? We are able to determine all of them. So how many cannot be determined? 0. The answer was 0. And because it was a theta question and 0, a lot of people would have made an error over here. Next one. To how many workers did R2 give a rating of 4? R2 did not give a rating of 4 at all anywhere. And hence that answer is also 0. Next one. What rating did R1 give to Xavier? R1 to Xavier has given a rating of 3. So that's 3. That's again a theta question. Next one. What is the median of the rating given by R3 to the 5 workers? Now let's look at R3. R3 is 4, 4, 5, 5, 1, which means if I put it in the ascending order, 1, 4, 4, 5, 5. The median is 4. What is the median of rating given by R3? So median is 4, and that's your answer for this question. 4. Last question. Which among the following restaurant gave its median rating to exactly one of the workers? Let's look at R5 ka median. R5 is 22445. 22445, which means the median is given to 2 people. So that's not my answer. Let's look at R3. R3 is this. 14455. Same, you will get 14455, which means median to 2 things. R3 is not the answer. R4. 24413. That is 1, 2, 3, 4, 4. Median only to one of them. Answer will become R4, which is the third option. Right? So according to me, based on the other sets of this slot, I thought this was a much easier set to do and you could have easily done this set well.